One of the greatest unanswered questions and enduring mysteries of the modern world is this: why is there something rather than nothing? The first thinker to pose this question explicitly and to pursue it systematically was Gottfried Wilhelm Leibniz, the German mathematician, logician, and natural philosopher, best known as the co-inventor of calculus alongside Isaac Newton. This question was not central throughout most of earlier intellectual history. In antiquity, Greek philosophers were deeply concerned with the origin and nature of matter, but not with the concept of absolute nothingness. In Aristotelian philosophy, the universe is eternal. Aristotle introduced the idea of a prime mover, the cause of motion in the universe. But this was not a creator who brought the universe into being from nothing. Rather, motion and matter had always existed. The task of philosophy was therefore to understand the structure and principles within the universe, not to ask why the universe exists at all. This worldview closely resembles what modern science later called a static universe, a universe that has always existed and remains fundamentally unchanged on the largest scale. Remarkably, many major scientists, including Albert Einstein, believed in a static universe until the late 1920s. A significant shift occurred in early Christian philosophy and theology. Thinkers such as St. Augustine of Hippo, 4th-5th century, rejected the idea of an eternal universe and argued instead that the world had a definite beginning. This idea was later systematized by Thomas Aquinas, 13th century, through the doctrine of creatio ex nihilo. The denier was out of nothing. According to this view, time and space themselves began with creation. Therefore, there was literally nothing before the universe. This theological framework introduced the concept of nothingness into serious intellectual discourse. If the universe had a beginning, then how could something emerge from nothing? Given the limited scientific knowledge of the time, and a geocentric worldview in which Earth stood at the center of a small, finite cosmos, the most coherent answer was theological. There was nothing except God. God was conceived as a necessary being, non-physical, non-spatial, timeless, who brought contingent beings into existence. This idea of God as a necessary being became central not only in Christian theology, but also in Islamic philosophy. Thinkers such as Avicenna, Ibn Sina, 11th century, distinguished between necessary existence, God, and contingent existence, the created world. Since creation was understood as an essential attribute of God, the emergence of the universe from nothingness was considered inevitable. Fast forward to Leibniz, who was raised in a world deeply shaped by Christian theology. He accepted that the universe had a beginning and that nothing preceded it. Yet Leibniz reformulated the issue in a strikingly precise way. Why is there something rather than nothing? As a scientific genius, Leibniz sought mathematical explanations for natural phenomena. His development of calculus enabled him to explain the mechanics of motion and change. Yet the deeper questions about why they occur remained unanswered. He concluded that scientific explanation must eventually stop. The final answer for Leibniz could not be mathematical or physical, it had to be metaphysical. His conclusion was that the existence of the universe ultimately rests on God's sufficient reason. Anyone who has interacted with a curious toddler knows this pattern well. Every answer invites another why. Eventually, the questioning reaches a point where no further explanation is available, and the only answer is, it is time for bed. Humanity's inquiry into the existence of the universe follows the same structure. Despite extraordinary advances in science over the past century, from cosmology to quantum physics, we still lack an answer to the fundamental question of why anything exists at all. Now let us turn to modern science. In 1915, Albert Einstein introduced general relativity, a revolutionary theory that treats space and time as physical entities, a dynamic fabric that can curve, stretch, and interact with matter and energy. Space and time are not passive containers, they are part of reality itself. This raised a profound question. If all matter were removed from the universe, space and time would still remain, like an empty room without furniture. But what if space and time themselves were removed? Would that be the true nothingness? Although general relativity reopened the question of nothingness, Einstein himself remained committed to a static universe. Ironically, it was other physicists who used his equations to reach a conclusion he resisted. The first was the Russian physicist Alexander Friedmann, who showed mathematically that Einstein's equations allow for an expanding universe. Independently, the Belgian priest and physicist Georges Lemaitre reached a similar conclusion and proposed that the universe originated from a highly condensed state he called the primordial atom. Einstein initially rejected these interpretations, even when confronted with Friedman's mathematics. Later, when Lemaitre presented his model, Einstein reportedly called it abominable, not because of mathematical errors, but because it contradicted the idea of a static universe. This resistance ended in 1929, when Edwin Hubble observed that distant galaxies are moving away from us, with their light shifted toward the red end of the spectrum. The farther away a galaxy is, the faster it recedes, a discovery now known as Hubble's law. Einstein accepted the expanding universe shortly thereafter, famously calling his earlier insistence on a static universe his greatest blunder. The implication was astonishing. If the universe is expanding, then tracing time backward leads to a moment when space and time themselves emerged. This became the foundation of the Big Bang theory, which places the beginning of our observable universe about 13.8 billion years ago. Yet even modern cosmology does not settle the question. Some contemporary theories suggest that the Big Bang may have been merely the beginning of our observable universe, possibly one event among many in a larger multiverse, or preceded by earlier cosmic phases. But even if this is true, the question remains untouched. What is nothingness? Why did it not remain nothing? And why is there something rather than nothing? Science has pushed the boundary of explanation farther than ever before, but the mystery itself still stands.